I think to all of you.
Sir,
You
you
can
are
reply in the chat section.
Yes, sir. Good evening, sir.
Hello all.
sir, you are audible, sir.
Yeah. Okay. So recording is on sir.
Yes.
Okay. Sir. So yeah. So today actually we are going to start, the subtopic of the fluid mechanics. That is again a subject of, we can say, aerodynamics, right? This is the fluid mechanics. So in that fluid mechanics, we are going to cover boundary layer theory, right? So before starting our discussion about the boundary layer theory, I would like to know how many of you are aware of this boundary layer theory at least. If you know something, you can write in the chat sections so that I can be, aware that in what level you know this particular topic. Yes. It can be anything. If it is wrong also, no need to worry about that. Any one of you? Okay, so yeah. So boundary layer theory, basically in this boundary layer theory, what is happening? Whenever we take any example, this boundary layer theory, let me put the heading. Boundary layer theory, laminar flow, turbulent flow, and energy equations. Yeah, but I'm asking basically what is the main significance of studying this particular topic, right? So very first reason, if I'll be asking you, what is a boundary layer, right? So the reason, of course, we are discussing this topic because we have a lot of motivation to study this topic. The very first motivation is that, being from aerospace, right, domain, what you can just have a motivation that, suppose if we take a air wing, right, or maybe, the wings of the aeroplane or the profile of the blade, right, aerofoil section will be there. And in that aerofoil section, whenever you place that aerofoil in the free stream conditions, right, or whenever this blade or aerofoil section will be passing through basically wind section or maybe in a free stream conditions, then what is going to be happening? There is a suddenly some kind of, region will be developed. Of course, that is an imaginary regions. We don't see actually with our own eyes. That region will be very thin layer, something like this. Of course, I'm zooming right now, but it is a very, very thin. If I'll be telling you by the example of flat plate, and the fluid is flowing over the flat plate, what is happening? A very thin layer of the boundary layer will be developed over that flat plate, something like this, right? And of course, this is a boundary layer. As of now, I'm just giving you overall. Let me give that particular point so that you'll be getting some idea. This is a boundary layer. Now, what is the significance of highlighting this boundary layer? That is the next question, right? And the next question, that is the second question, will be, what is the reason for boundary layer formations, right? So we have few questions to answer. Question number one, what is the physical significance of boundary layer? And the question number two will be, what is that? What is the reason for boundary layer formations? Now, for understanding these two questions, you must be stick to 1 hour class, right? Then only at the end of the particular session, you will understand the physical significance as well as the reason. Reason, of course, I will be telling you very quick so that you can understand, the reason for boundary layer formations. So very first thing is that the boundary layer approximation bridges the gap between the Euler equations and, Navier-Stokes equations. That means it is differentiating the gap between the slip condition and no slip condition at the solid walls. Of course, at this particular point of time, you might not be getting this anything from this particular three lines, right? But just note down, in the next slide, I will be discussing about this, all these definitions. Very quickly, just make a note of it. Now, anybody know what is the difference between real fluid and ideal fluid? Anybody know the difference between real fluid and ideal fluid?
Sir, ideal means without viscosity. That is
Don't have
inviscid.
viscosity, yes.
Inviscid.
So whenever we talk about the ideal fluid, so ideal fluid is actually don't have any viscosity, but in real life, we don't have such kind of fluids. It might be possible that those type of ideal fluid or inviscid fluid will be called as, not exist in reality. But in reality, what is exist? Real fluid. Real fluid will be having some kind of viscosity, but the real fluid can behave just like an inviscid flow. How? Let's see. Yes, I think screen sharing is off, right?
Yes, sir. Yes, sir. Is off.
Yes.
Now it is there, visible.
Yes, sir.
Visible, right? All of you?
Yes, yes,
Correct.
yes, sir.
Yes. So let me explain you the boundary layer formations. Let me consider an example of the flat plate. Everybody know that whenever the plate will be placed in a free stream conditions like this. This is the flat plate. Now let me take some more, length of the plate so that we can discuss in detail. Now this plate is fixed one. Now if the plate is fixed one, that means velocity of the plate will be 0, right? Now consider this section is what Z particular axis. This axis will be X and this axis will be Y. So I have given the notations also about the axis. Now what is happening? The free stream is flowing like this. In a particular environment condition, each and every fluid layer will be flowing with the velocity called U infinity. What is the meaning of U infinity? Free stream velocity.
Without disturbance.
Without disturbance, free stream velocity. If there is a no disturbance, every fluid layer will be moving with the what? Same amount of velocity, right? Each and every fluid layer will be moving with the same amount of velocity. The moment they will be in contact with the plate, what is going to be happening? Suppose this fluid is what we can take as air at 25 degrees centigrade. And this particular air is having some kind of viscosity. Viscosity is not 0. What is the meaning of viscosity? What is the meaning of viscosity? You can just note down. Viscosity means ability of the fluid material to resist the motion of what? Adjacent fluid layer. Can you say like that? It is a property of the fluid layer. It is a property of the fluid element in such a way that it offers some resistance to adjacent fluid motions, right? That means suppose two layers are there which are flowing in the same direction, but one layer is flowing with the direction u, but other fluid layer is moving with the direction u plus du. So what it will say? The second fluid layer, what the communication will happen between second fluid layer and the first fluid layer? The second fluid layer will say that come back, and they will apply the resistive force like this. Is it correct? Check it out. All of you are getting my point or not? How the viscosity phenomena is happening. Viscosity is basically a fluid property by means of which each and every fluid layer is offering some kind of viscous resistance to the adjacent fluid layer. Is that clear? Check it out. If that is not clear, then we cannot discuss about the boundary layer concept. Tell me guys, reply in the chat section whether it is clear or not. Yes, clear. So this is the viscosity. Basically, you can say in a very simple word, it is a resistance to the fluid motion. That's it, to the adjacent fluid motions. Now coming back to this particular boundary layer and taking the advantage of learning this viscosity, the moment fluid layer, the first fluid layer, let me take 1, 2, 3, 4, 5th and 6th. There are 6 fluid layers are there. The moment first fluid layer, they will be in contact with the flat plate. What is happening? What is happening? Because fluid is having some kind of viscosity. Now, it is whenever the moment it will be in contact with the flat plate, it is going to get the zero velocity. The fluid layer of the first particular fluid layer is going to have zero velocity. Why? Because to satisfy no slip conditions. Now, what is the meaning of no slip conditions? No slip condition means there has to be no relative velocity
Zero velocity.
between fluid layer and solid body. That means if solid body is moving with the velocity u, the fluid layer which are coming in contact with the flat plate or any solid body, they must also be moved with the same velocity. Now, if it is zero, to satisfy no slip condition, it has to be zero. The first fluid layer, it is going to have zero velocity. The moment you move in the transverse direction, what I'm calling this to be y direction, I'm calling right now transverse directions. This is known as longitudinal or axial direction along the length of the plate. But I'm just moving in the above directions. The moment if I move in the transverse direction in the y direction, what the velocity of the second fluid layer? Will it be lesser than u infinity, or will it be more than u infinity, or will it be less than u infinity? Just thought of that. The moment you just move in the y directions, the second fluid layer is going to have the lesser velocity than u infinity. It is going to have the lesser velocity as compared to u infinity. Why it will be lesser velocity? Because the first fluid layer which are in contact with the flat plate, the communication will happen between second fluid layer and the first fluid layer. And what the communication will be happening? This first fluid layer will be saying to the second fluid layer, how can you move forward with the same velocity u infinity? Can't you see I'm at the rest conditions? And if I'm at the rest conditions, you know that we have a lot of bonding with each others. Yes or no? Viscosity, if I just talk in terms of liquid, what is the reason for the viscosity? Cohesive forces, right? That means there is a lot of bonding forces will be there. There are a lot of bonding forces will be there between the what we can say, fluid element. If there is a bonding is there, then how the second fluid layer can move with the same velocity called u infinity? It has to move with the what? Somewhat lesser velocity. Is that clear now? So what is going to be happening with the third fluid layer? It is also going to move with the what, little bit slower than u infinity, like this, and it is keep on growing in the transverse directions till it is going to develop the velocity which is equal to 0.99 times of u infinity. Check it out. Now, at the point, this particular point, let me call this particular point to be point number 1. What is happening at the point number 1? There has to be certain distance the fluid particle has to travel to achieve the free stream velocity, right? So why there is a velocity differences among the fluid layer in the transverse direction? Then what you will say? Because of the property called viscosity. Are you getting my point? Tell me, guys. If I am going to move in the transverse direction, there is a difference of the velocity is happening among the fluid layer. And what is the reason for the difference in the velocity? Because of the property, because of the one messenger from the wall, and that messenger is what? Viscosity. Is that clear now? Now, if you come back to this particular section, this is a section I'm calling this section to be 1-1. Let me take the section 2-2 over here. At some distance away from the initial part of the plate, let me just take you to the section 2-2. And if I'll be taking you to the section 2-2, what is going to be happening? The first fluid layer is going to have the zero velocity, and slowly in the transverse direction, what is going to be happening? Whether velocity will be increasing or decreasing. That is the first thing I will be asking you. If I will be moving along the section 2-2, what is going to happen? The first fluid layer, it is going to have zero velocity. What about the second fluid layer? It is going to have more velocity than this one, or what? Let me call U2, U3, U4, U5, U6. That means the velocity of the second fluid layer, third fluid layer, fourth fluid layer, and fifth fluid layer. At this section, now tell me whether velocity will be equal to u2, or will it be less than u2, or will it be more than u2, or will it be more than u infinity? Tell me, guys. See, at this section 2 to what is happening, the more and more fluid layer will be coming in contact with the flat plate, effect of slowing down will be more and more, because more and more fluid will become to know that okay, there is some solid object has been placed in environment conditions, and that particular body is kept in the rest conditions. And if that particular body is kept under rest condition, what is going to be happening? There has to be some retardation in the flow directions. In the transverse direction, there has to be reduction in the flow. Are you getting my point? Now, with that segment, it is going to have lesser velocity, u2 dash. u2 dash will be less than u2, less than u infinity. And now at this section 2, the fluid layer, they have to travel more distance to achieve the free stream condition. That means they have to travel this much of distance, maybe more than that. Slowly it is increasing, because now effect is more severe. Effect has been felt more severe. Something dragging is there. Those who are basically what? Not able to move this particular fluid layer so smoothly, right? Check it out. And at one particular point of time, it will reach, this is the second point, where it is achieving 0.99 times of u infinity. Now just check it out. This is delta 1 and now this is delta 2. Now why delta 2 is more than delta 1, whether it is clear or not? Delta is nothing but boundary layer thickness. What is the delta? Boundary layer thickness. All of you are getting my point or not? Tell me, guys. Whether you are understanding the communication between the fluid layers, which are happening in whenever they will be coming in contact with a flat plate. Please check it out. All of you, please respond in the chat sections. All of you are observing what I'm saying. Check it out, guys. What I'm saying, just have a look at once again. I will be writing each and everything, but try to understand from initial starting segment. The free stream velocity is the velocity which is achieved by the fluid layer without any disturbance. The moment they will be get disturbed by the flat plate, this is the flat plate. The moment they will be disturbed by the flat plate, what is going to be happening? There is a difference of the velocities coming in the transverse directions. And why there is a difference of the velocities coming in the transverse direction? Because of the property called viscosity. Every fluid is having some kind of property. That property is called as viscosity. Because of that viscosity only, they will offer some kind of resistance to adjacent fluid layer. And that's the reason the first fluid layer will offer some kind of resistance to the second fluid layer, so that they will not be able to move with the velocity called u infinity. They will be moving with the velocity u2, which is lesser than u infinity. In such a way that now again you will be asking me, sir, in the y directions, why the velocity is increasing? You might be thinking, sir, why third fluid layer is having more velocity than second fluid layer? If it is coming in contact with a flat plate, solid wall, it has to decrease velocity. But why it is increasing? Why it is increasing means above third layer, more fluids are there. They will transfer their momentum. They will say, hello guys, why you kept at that particular positions? See, there is a competition is happening between, see, this is the second fluid layer, U2. Among that, there is a various fluid layer which are moving with a very smoothness, because effect of wall will not be felt because they are some farther distance from the wall. But the first fluid layer, he is facing more difficulties. He is saying that I am suffering. How can you guys move with such a flow intent? With such a very flow condition, how can you move forward? So I will be definitely stopping because of the competitions. And in such a competition, what is going to be happening, my dear friend? The moment first fluid layer will offer some kind of resistance, something like this. Shear force, if it offers to the second fluid layer, the second fluid layer will say, why I will be stopping if I am having some kind of momentum from above side. And what is the meaning of momentum? Mass flow rate into velocity. And this velocity they will transfer to this second fluid layer. So with that, the second fluid layer will not be at the rest condition. It is also moving with the velocity called U2. Of course, lesser than u infinity, because effect of wall has been what? Felt, because it is not that much farther, right? From the wall. So effect will be felt. But as you keep on moving in the y direction, further and further, the effect of messenger or effect of wall will not be that much felt. They will feel like nothing is there, no plate is there, like that. But suddenly, what is happening? The moment the fluid particle achieve 0.99 9 times of u infinity, after that, they will move with the velocity called u infinity. After that, they will move with the velocity called u infinity. There is a region which is basically demarcating between the viscous region and non-viscous region. That region will be, that particular layer will be called as boundary layer. What is that? Now, if I join from basically from the locus of the point where it is getting the velocity to be 0.99 times of u infinity, and if I join that locations, I will be getting one layer. This layer, this black color layer, will be called as boundary layer. Please make a note of it. Inside the boundary layer, many things are happening. Outside the boundary layer, all the things are same as free stream conditions, because outside the boundary layer, effect of wall is not being felt, and the distance by which it travels, the distance by which the fluid element is traveling to attain the free stream velocity, it's called as boundary layer thickness, delta. But as we move towards the length of the plate, and basically as we move forward, as we march along the x direction, why the boundary layer thickness is growing? Because effect of slowing down will be more and more among the fluid layers. Are you getting my point? See what the communication will happen now between third fluid layer and the second fluid layer. Second fluid layer will be saying that I'm feeling so much of stress conditions right now because of my bottom layer. They are at the rest conditions. Third fluid layer will also say that no worry, no need to worry, I am transferring some momentum. The moment it is transferring some momentum, but how can it transfer the momentum? Because if momentum itself will be reduced, because if the velocity will be reduced, the momentum transfer will also be reduced, right? Because more and more amount of fluid layer will be coming in contact with the what? Solid surface, flat plate. This is a 3D figure. So more and more fluid will be coming in contact with the flat plate. Effect of slowing down will be more and more. That's why they are taking much more distance to achieve the same 0.99 times of u infinity. Of course, we are not bothering about the 100%. 100% achievement is not possible always. So we are just happy with the 99% of free stream conditions. Is that clear now? So if I'll be asking you physical significance, what are the physical significance? That we are going to discuss in the next slide. But before that, you just make a note of it. All of you are getting my point or not? Till now, we have not answered any question. I'm just telling you why this boundary layer formation is happening. That's it, right? So please just make a note of it. And after that, we have a lot of interesting phenomena related to this boundary layer. The moment you got the boundary layer, everything is sorted out. Of course, this is a very, very imaginary thing. It's just our imagination, or maybe it is not visible in the experimental conditions, but still we are very happy with that because it is not demarcating between the two flow domain. One is viscous domain and another is what? Non-viscous domain, right? Non-viscous domain, we basically refer to call this to be as inviscid zone. Now, you try to observe what is the meaning of inviscid flow. Anybody know? I keep on talking about the inviscid flow, but till now I have not discussed about anything about the inviscid flow. Tell me, guys. Inviscid fluid, which is having zero viscosity, but inviscid flow is different than the what we call ideal fluid or maybe inviscid fluid. Anybody know? Once it is done, let me know, guys. Once all of you have noted down, let me know. Is it done, all of you? All of you have noted down? All of you have noted down? Yes? Tell me, guys. All of you have noted down? Perfect. Now you try to understand what I'm telling to you. Suppose there is a flat plate, and in the flat plate, basically, boundary layer formation is happening. The moment the fluid is flowing over the flat plate, there is the boundary layer formations will be happening something like that. The moment boundary layer formations will be happening something like that. So what is going to be happening? This is what the boundary layer formations is happening. Inside the boundary layer, this is what we have boundary layer. Inside the boundary layer, we have the viscous region. Now, what is the meaning of inviscid flow? Inviscid flow means the shear force will be zero. If the shear force will be zero, shear stress will be zero. And according to Newton's law of viscosity, shear stress is what? Directly proportional to velocity gradient, mu into dou u by dou y. Viscosity is not zero. Everybody know that. So what has to be zero? Dou u by dou y must be zero. Now what is the dou u by dou y? What is the velocity gradient in the y directions? Velocity gradient will be something like this. Theta. How to calculate theta? How to calculate theta? Du by dy. Are you getting my point? Basically, we are doing partial differentiation because it may be the function of x or it may be the function of pure y. So we are bothering about only partial differentiations. So this is what we are writing based on what? Newton's law of viscosity. Right? This is what the very first chapter called fluid properties. So the moment what you are observing outside the boundary layer, whether any slope is there, any velocity gradient is there. Check it out. Any velocity gradient is there at the edge of the boundary layer. At the edge of the boundary layer or outside the boundary layer, dou u by dou y will be there. That is zero. Dou u by dou y will be zero. If dou u by dou y will be zero, viscous forces will be zero. And the viscous forces will be zero. That zone will be called as inviscid zone. Inviscid flow. Inside that boundary layer, the dou u by dou y is not equal to zero. Shear force is not equal to zero. That means that particular domain is called as viscid zone. Now tell me outside the boundary layer whether we have the rotational flow field or irrotational flow field. Tell me guys. See, if the shear force is not equal to zero, if you take the fluid element, this fluid element is rotating. Suppose that. Who will able to rotate the fluid element? There has to be some shear force, right? And if I take the torque about O point, what is the torque value? Fs into R. The moment Fs is not equal to zero, the torque will also be not equal to zero. Am I right? The moment Fs is not equal to zero, the torque will also be not equal to zero. Yes or no, guys? Check it out. All of you, please check it out. If the shear force is not equal to zero inside the boundary layer, the torque will also be not equal to zero. And if the torque is not equal to zero, this fluid element will be start rotating. That's why inside the boundary layer, we also say that it is a rotational flow field. But outside the boundary layer, we don't have such a kind of torque phenomena because here the viscous force will be zero. Shear force you call or the viscous force, all the things are same. And if that is equal to zero, this zone will be called as irrotational flow domain. All of you are getting my point? Tell me guys, one by one, each and everything are clear or not? Yes, you try to focus at least, right? Whatever you want to gain, you can just gain, but it is a very, very important session. Now, if I'll be asking you one thing, what is the meaning of Euler equations? Euler equation is basically which consider inertia force, and pressure force. Of course, inertia force is a resultant of pressure force and gravity force. Am I right? That's it. There is no viscous force in the Euler equations. Euler equation does not consider any viscous force. That is zero. But if you just consider Navier-Stokes equations, it is the summation of all the three forces: viscous force, pressure force, and the gravity force. Now tell me, inside the boundary layer, can we apply the Euler equations? Inside the boundary layer, at this point, if I'll be asking you, can we apply the Euler equations? We can't apply because viscous forces will be zero. If the viscous forces will be zero outside the boundary layer, here we can apply the Euler equations But inside the boundary layer, we cannot apply, we have to apply Navier-Stokes equations. Please make a note of it. Very, very important. So these are the very basic fundamental. Now here, if you just observe this figure, this two figure, Navier-Stokes equation, they are following the no slip conditions. One reason why the boundary layer formation is taking place because of the no slip conditions, and one reason is viscosity. So both the reasons are responsible for the boundary layer formations. If that reason is not there, suppose if you take the flat plate and the fluid is flowing over the flat plate, but they are not following the slip conditions or no slip condition, that means what? They will slip. The moment they will slip like this over the flat plate, whether they will form any boundary layer, check it out. At this zone, there is a slipping is happening between the flat plate and fluid layer. Whether any boundary layer formation will be taking place, check it out. Please tell me, guys. No boundary layer formation will be taking place whenever the slip conditions are happening. And why the slip conditions are happening? Because you are hypothetically assuming that viscous force is zero. Viscous force is not zero, but you are still assuming that the viscous forces are zero. And if at all viscous forces will be zero, indirectly you are applying inside the boundary layer Euler equations. Indirectly you are applying Euler equation means what? Unnecessarily you are making the assumptions of what? You are assuming what? Condition to be slip condition. That means slipping will be taking place, and the moment slipping will be taking place, no boundary layer will be forming. But if you just apply the Navier-Stokes equation is considering about the shear forces, viscous forces, right? They are considering about the viscous force or shear force. Let me call FV or FS. Both are same thing. So if they are considering about the shear forces, that means they are talking about the rotationality. This means they are talking about the velocity gradient. It means they are talking about the no slip condition. Yes or no, guys? Is that clear, this particular figure? So that's why it is said that the boundary layer bridges the gap between Euler equation as well as Navier-Stokes equations. Is that clear? That particular three-line definition they have given. So the moment you are applying the Euler equation to the flat plate, slipping will be happening. The moment you are applying the Navier-Stokes, slipping will not be happening. No slip condition will be justified. That's why it is said that it bridges the gap between slip conditions, that is the Euler equations, to the Navier-Stokes equation, that is no slip conditions. Is that clear? Why this person is at the rest condition? Because this structure is at the rest conditions. Are you getting my point or not? Check it out. Tell me, guys, is that clear? I don't know how many of you are getting my point. Please reply in the chat section so that I can come to know. All of you are getting my point? Tell me, guys. It is not that much tough. Everything is very easy, very comfortably. You can understand. See, within one diagram, I can give you a lot of 10 to 20 questions based on that only. Only based on the flat plate explanation, I can frame number of questions, and that they are throwing in the GATE examination for the past 30 years. Right? So please, if it is done, let me know. I can move to the next slide. Is it done? I think done, right? All of you have noted down, right? What is happening? So all of you have noted down that particular thing, right? Yes or no? All of you have noted down? Yes or no? Tell me, guys. So note down one simple definition. So so that you can understand the concept of boundary layer. A very simple definition about the boundary layer formations. What is the definition? A boundary layer is a very thin layer the boundary layer is a very thin layer which separates in viscous and the viscous region. Please make a note of it. All of you are getting my point or not? I'm not getting that much reply. Is that I'm telling you very tough kind of things or what? Tell me, guys. All of you are getting my point or not? Yes. Correct. So just note down. I think it's all right. So one thickness you got to know, that is a boundary layer thickness. The second thickness I will be explaining you about displacement thickness. Just note down. Why it is getting all of you can see my slides? All of you can see my slides? Note down displacement thickness. Note down displacement thickness. What do we understand by the displacement thickness? Of course, within short span of time, whatever the thing I can cover from the very basic or very scratch level, I will be discussing. But the moment we are going to start our course, you will enjoy this session like anything, right? So displacement thickness. Anybody know about the displacement thickness at this point of time? First of all, note down the definitions. Whatever the things are written in the slides, you just note down. The displacement thickness is that distance that is streamlined just outside the boundary layer, deflected away from the wall due to effect of boundary layer. Why there is a boundary layer, why there is a displacement thickness is basically formed, there has to be some reason, right? See, for explaining those reasons, let me explain you. Everybody know about the mass conservations? Tell me, guys. Everybody know about the mass conservations? There is a flat plate. Because of the boundary layer formations, a lot of phenomena are happening. A lot of phenomena. Let me explain you one by one. Suppose this is a boundary layer formations. And the moment we got to know there is a free stream flow which is flowing with the velocity called u infinity. And the moment we have the boundary layer formations, we have the something like this. Variation will be something like this. Now, whatever the boundary, the velocity profile, what is this? Whenever over the flat plate, because of the boundary layer, whatever the profile is there, we call velocity profile. It is not necessarily that always it will be parabola. It can be anything. What is this? Velocity distributions. It can be linear, it can be parabola, anything. Let me take example for the, example of the linear velocity profile, right? And now it is basically framing at a distance of delta. What is that delta? Boundary layer thickness, right? Now tell me, I will be taking one zone, something like this. Initially, a streamline will be flowing just like that, like this, parallel to the flow. Am I right? This will be the streamline or not? Initially, the flow is happening parallel to each other. So can you say the streamline will be something like that? Check it out. All of you, please check it out. Streamline pattern of the streamline will be same or not? Will be parallel to each other or not? Correct. But after the boundary layer formations, the moment the fluid layer will be coming in contact with the flat plate, the pattern of the streamline will no longer will be parallel. The pattern of the streamline will be start shifting. And how the pattern will be start shifting, that is a matter of concern. That is a matter of concern. And what is the matter of concern? See, at this section, consider this to be outside the boundary, outside this flat plate, consider section 1, and you consider this to be section 2. Now tell me, what is the mass flow rate at this section 1. What is the mass flow rate at section 1? So what is the mass flow rate? See, this is the delta and the width of the plate. Let me call width of the plate to be W. This will be the area for the flow or not? Over which the flow is happening. Check it out. So what is the area of the flow? Delta into W. Can we write like that? So what is the mass flow rate? Rho into area of the flow into what? Free stream velocity. Then what we can write? Rho into U infinity into delta into width. Can we write like that? This is the mass flow rate at section 1. Check it out. Can we write like that? Tell me, guys, whether you know anything or not. Then only I can, on the basis of that, I can come to know. Otherwise, it is just a blank spaces for me. I don't know whether you are getting my point or not also. Only if you guys are responding. Right? Now, because it will not cost you that much. If you write something, anything will not be happening, right? So that's the reason you please write in the chat sections. Now, what is the mass flow rate? What is the meaning of mass flow rate? Mass flow rate is rho into discharge. That is a very fundamental thing. Of course, we are starting our discussion from the fluid properties till the boundary layer formations, or maybe, whatever the syllabus is there. Each and everything will be covered. As of now, I cannot discuss how we are getting the mass flow rate, what is the derivation for that. Within a short span of time, I cannot discuss much. I want to discuss, but time is not allotting me, right? So now what is the mass flow rate at section 2.2? See, mass flow rate at section 2.2 cannot be directly written as we are writing over here, because what is that? Velocity is not a constant one. If the velocity is not a constant one, velocity is varying with the direction, with the values of the y. As we keep on moving in the y direction, velocity also keep on increasing. And for the linear velocity profile, we can write at any layer. What is the velocity we can write? We can write U infinity into y by delta. Check it out. Can we write like that? You can verify at y equal to 0, put y equal to 0, u 0. Put y equal to delta, u must be u infinity. U must be u infinity. Is it satisfying? And why we are calling linear? Because y is directly proportional to y to the power 1. It's a linear velocity profile. Now, my different. What is the mass flow rate? Integrate it. And if you just do the integration, what is going to be happening? Rho will be there. Area will be what? Area I'm considering dy distance, dy thickness, into width. So dy into width. And what is that velocity of that particular layer? Suppose that it is moving with the velocity u. Do the integration from 0 to delta. What are you going to get, my different? Dy into width. U is nothing but what? U infinity into y by delta. Now, my different, what is the mass flow rate at section 2.2? Rho into width value by delta u infinity into y square by 2. So what you are observing, mass flow rate at section 2.2 will be, what is that? Rho into u infinity into, rho into u infinity into delta into w by 2. Check it out. Can we write like that? Can we write like that? Tell me, guys, yes or no. If no, then please tell me no. If yes, then tell me yes. That is going to be happening with my classes also. I will keep on asking yes or no. Whether you are frustrating or not, I don't matter. It doesn't matter to me. But until unless I will be getting from you reply, I will be just feeling that I'm just telling to some robot. I mean, that means he is not responding, something like that. Right? Now, what you are observing, my dear friend, at this section mass flow rate is suppose m dot, at this section mass flow rate become m by 2. And you know from the mass conservation, mass cannot go anywhere. Mass has to be conserved. If it is mass flow rate m, at this section m 2, where the mass flow rate remaining? Is it earth has taken? Is it the sky has taken? Nothing is possible. Then where it is gone? Where it is gone? Tell me, guys. Remaining mass flow rate, where it is gone? Because of the boundary layer formation, my dear friend, the full zone is not occupied. Why a reduction in the mass flow rate is happening? Why there is a reduction in the mass flow rate? Because full region of the flow, this is the missing region. This red color which I'm making at this point of time, this is a missing region. Full velocity is not occupying completely because of the boundary layer formation, because of the viscosity, because of the no slip condition, because of the effect of wall. And because of that, mass flow rate is what? Become half. Of course, this is value only for the linear velocity profile. Remaining mass flow rate will be happening through like this. And that's the reason, that's one of the reason the pattern of the streamline will be shifted like this. Again, it is getting stuck. Just wait. The moment there is a reduction in the mass flow rate, what is happening? The mass flow rate will have to be somewhere, it has to be something. Mass cannot be go anywhere. If there is a mass flow rate m, at this section 2 also there has to be mass flow rate what? M dot only. It cannot go anywhere. It cannot go anywhere, right? Check it out. Yes. At this section 1, if there is a mass flow rate of m dot, but at section 2, the mass flow rate will be m by 2, right? What about the remaining mass flow rate? It has to be something, right? It has to be there with this section. And because of that, additionally, we provide flow over the flat plate. If you just observe, because of the boundary layer formation at section 2, we provide some extra area in terms of displacement thickness. Now, if you provide more area, can we increase the mass flow rate? What is the mass flow rate? Rho into area into u infinity. Let's suppose that velocity I cannot increase beyond the infinity. What I can do, if I want to further increase the mass flow rate at this section 2, I have to increase the area of the flow. And how we are increasing? By providing some extra area in terms of displacement thickness. Is that clear now? Right? So just note down one more definition of boundary this displacement thickness. What is that? It is defined as the distance measured perpendicular to the boundary of the solid wall perpendicular to the boundary of the solid wall, by which the boundary should be to compensate for the reduction in the mass flow rate. On the account of boundary layer formations. Please make a note of it. And now what is the formula? This is the formula. 0 to infinity, 1 minus u by u infinity into dy. Again, we will see some of the gate question on the basis of that. So indirectly, the pattern of the streamline which were initially no, parallel to each other, now they will be shifted something like this. They will be start shifting like this. Now, when they will be start shifting like that, one more reason you will observe very clearly here that this is the wall, and now there is a boundary layer formations, and the streamline will be shifted like this. Now, at this section, if you just observe, and at this section, to achieve the same U infinity, as we move along this flat plate, it has to travel the more distance. That's why delta 2 is more than delta 1. One more reason is there why delta 2 is more than delta 1, because streamline is start shifting in the upward directions, right? Here they have given the velocity profile, that is laminar, incompressible. Use nothing but the free stream velocity. They are asking what is the black color area which is shaded over here. What is that? Because of the boundary layer formation, this will be the velocity profile, but they are asking what is it. This is nothing but missing flow that I told you. Missing flow region. Full flow has not been occupied. The full flow is not been occupied. When the full flow is not occupied, then there is a loss in the reduction in the mass fluid. The same area I'm providing in terms of what? In terms of displacement thickness, something like that. So indirectly, this area and this area will be same. Whatever the reduction in the area will be there, that much of area I'm providing, so that the mass flow rate at this complete section 2 will be m dot. What where initially is there at 1 section, the same mass flow rate will be there. So correct option will be C. Right? Of course, displacement thickness into width. That must be the complete area which has shaded. Right? All of you have noted down? Again, sir, it is happening. Consider a study two-dimensional. Okay, I can write because so I need to stick to this particular page only. So yes. Now, if you just observe this question very carefully, what the question they are telling, consider a steady two-dimensional incompressible flow over the non-porous. What is the meaning of non-porous? Non-porous means though no flow can taking place perpendicular to this, plate. There is no hole, nothing is there. So the V component of the velocity will be 0. That means the flow is happening in the only in one directions. For the control volume PQRS, right? So they are giving the velocity profile UI something like this. They are asking the value of the A naught for which the flow through section PS, whatever the flow which was happening. I told you why the flow will be happening, because to satisfy the mass conservations, right? Because of the boundary layer formations, that much of mass flow rate we are not getting because of the account of boundary layer formations. But in this question, they are asking adjust the value of the A naught such that here the mass flow rate will be 0 through section PS. Now, according to mass conservations, what you can write? Here you can write mass flow rate through section PQ, that must be equal to mass flow rate through section PS plus mass flow rate through section SR. Can we write like that? If you just observe this control volume, whatever going, whatever coming, and whatever going out, can we write like that? Through this control volume, incoming must be going to what? Whatever going out. But they are asking in this question, this mass flow rate through section PS will be 0. That means this mass flow rate through section PQ must be equal to mass flow rate through section SR. And what is the mass flow rate through section PQ? rho into u infinity into area. What is the area? H into width, right? So this is the mass flow rate through section PQ. What is the mass flow rate through section SR? Again, they have given some kind of velocity profile that is not linear one. It's a non-linear velocity profile. So for that, we need to do integrations. And what is that? Rho into area of the flow. Area of the flow, what we can write? dy into width into u. At any layer, if you just take the velocity, that I can write something like that. So rho into width I can take outside. W is nothing but width. What is the u? A naught into y by h to the power n into dy. 0 to h. Now do the integrations. After integrating, what you will be getting? Why MPS 0? Because they mentioned in the problem. The flow through section PS will vanish. PS section. There's no flow is happening across the section PS. So rho into W into A naught that I will be taking outside, h to the power n, y n plus 1 divided by n plus 1 from 0 to h. So what is the mass flow rate through section SR? Rho into width A naught divided by h to the power n plus 1, h to the power n plus 1, like this. So here what we can write finally? Tell me guys. Rho into W into A naught h divided by n plus 1. Can we write like that? Now if you just equate this mass flow rate through section SR to this particular mass flow rate, so rho into U infinity into h into width, that is equal to rho into W A naught into h divided by n plus 1. So again I am writing rho W will cancel out, h will also cancel out. Then what is the A naught? N plus 1 into U infinity. What is the answer? B will be the answer. Check it out. All of you are getting my point? Is that question is clear? All of you. Is that clear? Hello, hello. Okay, guys.
Yes, sir. Anyone has any doubt? Is this clear? So this kind of question they ask in GATE exam. Okay. Uh, where is that guy? Sahil, are you there? Yeah, Sahil. So how much percentage you could understand today? Sahil,
Hello, sir.
yeah, hi. Yeah, tell me now.
Not much, sir, actually.
Yeah,
Because,
because
yeah.
it's a pure mechanical, right?
Yes, sir.
Yeah. So now I will ask Archana, how much